Hey everybody, this is going to be part 7 of our Treemap Viewer stream, which was a weekend project. It is now Sunday night. On Friday night, I decided, hey, I'm going to make this thing over the weekend. It's a thing I do once in a while. I should do it more often because they end up they end up being fun streams because we can build something from beginning to end with every line of code happening on the stream so everyone can see it. And that's what we did this time. So we built a viewer for a tree map, which is a way of packing a tree, more specifically a squarified tree map, as discussed in this paper. And we made a reusable module for it that any users of this programming language can use. And then we also added it into our pre-existing program data viewer. And that was very successful. So I'll just show that. People who have been following the streams will already know, because this is where we left off. Oops. Here we go. We can browse. We can load one of these files, output by the compiler, and here we go. And this is our program. And so to put this in context, what this program was before we added this was a viewer where there's a little record per procedure, and you have little doohickeys of how to sort things, right? But now we're packing the same amount of data on this one tree map, and it's pretty good. And I can see a lot of interesting facts and patterns that were not very obvious in the other view. And so I didn't actually expect this to get to the point where it was pragmatic. In fact, we actually already found and fixed a pretty weird problem that was generating like some pathological things. It's actually still a problem that I have to look into, but the most pathological case has been disabled. And so it's already done good use. And well, what more can you, like, beyond expectations, really, right? And so here's a tree map. The size of the function box, there's one box per function, and the size is approximately, the amount of code, although that's measured in a compiler way called, number of expressions, right? But, I can like zoom around in here and pan around, and I can look, and who's this? CRC. We have a very small module called CRC64 that, it does. If you know that, then you know what it does. Telemetry, etc. Now, we might always add more options to this. Like maybe you just want to see your program. Maybe you just want to see modules. Maybe you only want to see polymorphs, right? Which is, to be honest, a lot of the code. And I knew that before, but I didn't know just how much. And all these very regular things, as I sweep the mouse over, you see all these functions have the same name. It's because they're all polymorphs or, generic instantiations of the same function. And like, well, I feel like there shouldn't be that many. So that's something we get to look into too. But that's, that's the power of program visualization, is you get to, when it works, it brings you understanding that you wouldn't have had without it, right? Okay, all that said, there's a couple more things. Like, this is part 7. Normally, I would be maybe hoping to barely finish up at the end, but we're done. We've done a great job. Thanks me, apart from that 1 hour when I spent juggling stupid-ass matrix order in a hope of blindly fixing a bug that was something else. But not bad, all things considered. There's a few things I wanted to do. There's this thing about the border thickness not being consistent on the selection. I'll show the problem. So when I first launched the thing, it's because we just plugged this into some pre-existing code for that other mode that I showed you. So here you see it's a very thin rectangle, but then I go to the other mode, and now it's initialized the size based on the screen size, right? And now it's THICC. So let's fix that. That's easy, right? I think we're going to run out of things to do this stream, but that's easy. I hope. Codex use source. I really want to rename current. It's called current proc info. Yeah. Current proc rect is get rect. It said, okay, we found the place that draws it. So here we go. And now this happens. Oh, this is right. This is only for that other mode, actually. Wait, what? Oh, no, no, no. This is, okay. This is drawing. This is just setting current proc rect, right? So who uses it to draw? Looks like right here. So yeah. So we're expanding. So we're given some square, that's current proc rect, or some rectangle. We're expanding it by extra. And that's how many pixels. But what's current dx? What even is that? Current dx. This is, oh, this is how, okay. So based on how many, if you remember that line view, based on how many little pips we're trying to draw in there, if there's not very many, they're very wide, right? And as we try to pack more and more, we squeeze them narrower up to some minimum width. And current dx represents that. Now, that is not so good. I'm getting hungry. We're gonna make this simple fix, and then as a reward, how many pixels outward to expand the rects? Now we're gonna go, is the mode, oh, up here we already have an if for this. You know what? Does extra come into play outside this block? Nope. So all this can move in here. And this, so if we're in rows mode, which is that pips mode, right, we can do this. Extra is that. We're going to keep this. And then if it's tree map, I mean, I don't know. What do we want it to be for tree map? I think just, how about get line, right? We had get pixels of for the module border width. I don't know, like, that's just how I feel, right? GT, oh, we didn't, here we go. GT, boom, browse, circle band, okay. That's a little THICC. I mean, it's kind of unambiguous, but I think it's a little big, so. Try this. That's fine for now. It's actually a little bit, I mean, I guess we zoom in if it's, yeah, this is fine. I feel good about it. The area of the regions is linear with the function side. Any thoughts of logarithmic or some fractional power? We could do that. I just didn't want to do that for this because You know, I did it for this mode. So here, the bar height is log, right? If it's linear, well, this is because of that one giant thing. But this is the problem, is in this view, if you're in linear mode, almost everybody's a shrimpleton, because functions are kind of power law, right? At least if you didn't go to college at one of those classes where they say every function can't be more than 10 lines long. And so like here, that just ends up in you not being able to see anything, right? But part of that is just because we're normalizing to this unit size. So I think that's why this is so useful, right? And then there's like constant, right? Which looks neat in its own way. For the tree map, I don't feel like that's as much of a problem because like it's not normalized the same. It is normalized, but it's like somehow because we have an area and we're packing everything into the area, it's like normalized more to the mean size than the max. Whereas this one is normalized to the max because it kind of has to be. And so I don't feel like we get as much mileage out of that size tweak, but we certainly could do it. Like that would be an interesting thing to do sometime. I don't know if I want to do it tonight. We'll see. Anyway, that's one successful change. So I'm going to grab a snack and then we're going to do the next successful change. Well, hopefully it'll be successful, which is we're going to make this algorithm iterative instead of recursive, which I believe should be just very easy, but we'll see. Would it be straightforward to make the rectangles light up as the program executes? I wouldn't say totally straightforward, but we could do it. Like right now we have here, I might as well show this off, right? Actually, wait, I have to, is it, I think memory view. Good thing I wrote myself a note. All right, so if I run Sokoban now, it's going to take a little longer to start up because it's doing a bunch of memory tracking, but not that long. You can see we're cranking through the startup sequence, and it's also, well, it's a debug build with memory tracking. Oh, we crashed. Wow. Somebody made a boo-boo. Okay, well, we're going to have someone fix the boo-boo. So if we didn't assert an exit on an error like that, okay, well, we got one snapshot. So if we hadn't exited, you would see these snapshots continually streaming in where you could see everything, right? And that's all pretty cool. And you can see where the allocations and freeze happen. I'll be emailing the team about this one, though. We got an allocation for an address that the memory debugging system thought was still live. That's a weird one. That's a weird one. I'm going to have to maybe look at that. Okay. Someone's getting fired. It might be me, so don't get too excited. Anyway, so this would have been more exciting if it were streaming in, but this is a live memory report that you can get. So it wouldn't be, for some reason, I'm going to have to debug that at some point. That's pretty weird. But it wouldn't be that hard to make things flash as they run if you did live profiling, which we have a live profiler. It just doesn't talk to processes outside the program running it. The thing is that really useful though? Like, some things sound cool, but like, you know, Here's a really interesting thing about this game though, right? This is the main program. This is all the modules that we use. All the functions and all the modules that we use, including, and it's massively blown out by all these polymorphs, so it's like, I don't know, twice as big as it would be. I think a lot of programs are the other way around, right? Where the program itself is not that big, and it just uses tons and tons and tons of code. And we're not like that. We are using a bunch of modules. That's all cool, but yeah. Okay, let me get the snack, and we will continue. I'm also going to open a window a little bit. Modules are very efficient. That's true. If there were a 10,000 line printf function, you would see it here. You would see it here. I mean, definitely, you know, we don't have a way of searching by name here. That's maybe something we should do later. Okay, here's basic. This module is basic. So print, okay, here we go. This is the print file, this whole rectangle. So print item, print type, print U64. I mean, it's a non-trivial amount of the program, but it's like, you see all the line numbers are under 1,000. Oh, that one's 1,042, I lied. Okay, yeah, it's not a ton of code, really. Could show names in the rects. Yeah, I also thought about maybe showing them, you know, if you hold down the shift key or something. I'm not sure though. Like, what I want to do is try using this legitimately and just see what I feel like I need, right? Okay, iterative instead of, let's take the W before we ruin it. Fix inconsistent cursor thickness. Okay. Now, this function is called size children, right? And what we do is when it's time to recompute the tree map, we call this down at the bottom here. And what does it do? You call it on it's called root, but the root, changes as you go down. It's the local root. And we set up some stuff. We maybe call the border proc. That's the new thing. If the user wants to specify a border per node, let's do that. Specify borders per node. Okay. If the border they gave us was too thick, clamp the region to 0 size, we could enforce a minimum size. Okay, so we do all this stuff. So that's all set up for the node itself, everything from the top of size children down to here. And then this part is for every child. Let's do some math to lay it out, right? And actually, the way the algorithm works is, like I said, you could go read the paper, but for every new node that you want to add, you check, is it better, is it okay if we were to do this with it? And by this, I mean lay it out linearly with the existing line that you've been laying out. And if that makes it start to go bad, then you switch directions. And that works great. And so we do some math here. This is our little contribution where we removed the divides and made it nicer, for some definition of nicer. And then, if we don't like the shape that we would get, this is the part about switching directions and all that. Honestly, I haven't looked at this in a while, since yesterday. So maybe it could be simplified even more, but whatevs. Then we call flush nodes. Flush nodes actually sets up the size of all the nodes based on what we have done. And so here, yeah. We give it stuff. And flush nodes here is just like, okay, for all this stuff we gave it, it's got a total size. I use the word weight here, but that's sort of like the scalar size of the thing. We add that up for all the nodes, and then we just divvy up the coordinates based on whether we're horizontal or vertical. Anyway, you could read the paper if you really want to understand that better. It's a pretty simple paper. But this part is fine, but this part is recursive in the following way. We visit the root, we look at all the children of the root, and we're doing two passes here. We're doing the pass where we try to lay them out, and we flush them in little sub batches as we lay them out, and then we flush whoever's left at the end. And then this is pass 2, very simple, where for all the children we recursively size them. Okay, and the thing you'll note about this, I mean, if it's not totally obvious, it doesn't matter what order we visit the children, right? It's very easy. You're welcome. This has been a fun weekend project. I'm glad people are enjoying it. I'm going to upload the rest of the videos tonight and tomorrow. Yeah, where did the giant UI init go? That's the thing that I fixed. basically, it's a long story that I kind of explained yesterday, I think, but if you have arrays that you return from compile time execution, they get translated back into syntax tree, and due to a weird interaction, which I thought was totally a bug, but now that I look at it, it's kind of intended, kind of, question mark? Not really, but kind of. That ends up getting messaged back to your program. So if you have a very, very, very large array literal, it looks like it's in the syntax tree of your function in some cases, and that gets counted as expressions. And what happened was we load like 7 or 8 bitmaps when getrect starts up at compile time because we put them in the executable. And so all of those get messaged to the metaprogram and they go into the expression array for that reason. And they probably shouldn't, if I'm being honest, but I fixed it in the meantime by making it string, because a string is kind of opaque, right? As opposed to an array literal, which isn't totally. Anyway, thank you. I appreciate, I think a lot of people are enjoying this. There's something nice about doing a little project and it's visual. You see it happen on the screen, right? Because what we're doing is fundamentally graphical, so that helps. And it's small enough to understand and to get done in a weekend, and that's great. Yeah, I definitely want to do more of these if we can. Okay, so yeah, it's very different as opposed to like if people see me work on the Sokoban game, it's like a relatively large amount of code that's been going for years, and like you can't, you know, it's just not bite size in the same way. Okay, so let's do the thing. So instead, all I'm going to do is instead of this, actually, here's what we're going to do. We're going to have a stack, right, which is an array of pointer to, oh, this is weird. I guess, okay, we're not passing. Yeah, okay, this is fine. This is going to be an array of Treemap node, right? And we're going to stack.allocator is temp so that we use temporary storage. Now, we're going to add to the stack the root, right? Okay, and then here's what we're going to go. While stack, we're going to say size children. With that, display border proc, and we're going to pass the stack. Okay? Actually, but we have to get the root. How do we get the root? We say root equals pop stack. Not stack with a K. Well, with a K, but also a C. So we're just going to do this. And size children will add children to the stack, right? So stack pointer Treemap node. All right. And so this way, we won't end up recursing. What we just do is down here, instead of doing this, we're just going to go array add. This is our first cut. And once this works, we're going to do something else. Stack, comma, root, children. So just put the children on, put the lotion in the basket. And maybe it's not worth doing anything besides that, like mismatching levels of indirection, pointer to array of pointer Treemap node, gave array of point, oh yeah, well, duh. Ta-da! Well, that was all my ideas about what to do tonight. I don't know. I don't know, everybody. Did I delete the... All right, let's just delete that. Boom, we're done. Scale thickness of outline to size of square. I didn't really want to do that. I don't think that necessarily looks good. I mean, it looks a little bit funky down here, but just zoom in, bro. I don't know. It's actually pretty funky down here. What's a good way to do it? Because I don't necessarily think, I don't think a continuous adjustment is good, right? Because then things don't look uniform and it's bizarro, right? But maybe maybe we have a thing where we step down to half size if it gets below a certain amount. So like, you know, maybe around here, it's like starting to get too big, right? So maybe if our proposed border size is like more than 8 times the module size, we cut it in half. Sorry, if it's more than 1/8 the module size. I'm not a fan of scrolling to where the mouse is pointing. I mean, not really. This is more like an FPS player or RTS player. Like, I'm WASD plus mouse. Like, this is a fucking manly gamer way of navigating. It's not like a Mac user way of navigating, right? Okay. Let's just try that really fast. And I don't want to indefinitely shrink it, but let's just try. Okay, where was it? Was in lowercase Treemap. Okay, and just with the module thing, module border size. Width is min of if the region is very thin, step down the border, but we don't want to do this continuously since that looks bad, question mark, so we do it in discrete steps. But hey, let's do a max of 5 steps because of floating point error and stuff. Okay, so for 1 to 5, if B is less than, width is min, region, or outer dimensions dot x, outer dimensions dot y, okay. If B is less than 0.125 times width break, B times equals point. So we just cut it in half instead. Like, this is very, like, you know, you could do some math to figure out how many steps, but like, really? Let's try that. You know, that looks better. I'm gonna say it, although I think we start too soon because we're kind of starting out here. I kind of don't totally get, like, this looks about the same size as this. Anyway, so now we can see more. We can see more butts. Yeah, see, this looks weird though, because again, kind of the problem that I have with it is that it's ugly in the same way as we had before, where some guys are double and some are single. Oh, you know, we could do this in X and Y separate. Okay, here's what we do. BX, BY. All right, BX, BY. We do BX and BY separately since we want them to match neighboring regions without discontinuities. And if we size both, we tend to introduce visual discontinuities, both in tandem. In tandem. Okay, Trandom. It's the name of my band. Okay, for 1 to 5, if bx is less than 0.125 times outer dimensions dot x break bx. Okay, this is really stupid. Really stupid. I mean, yeah, I still think we started a little early. 0.125 is too big. Or too small. It's too small. But like this looks better though. See here we've got THICC on the left and then thinner here. Like there's always going to be a little bit of, you know, like, what's that? But I think this is an improvement, don't you? You didn't mind the consistently sized borders. Let's A/B test, all right? Here's what we're going to do. We're going to run our famous Adobe PhotoMaster. All right? And we're going to run here again. We're going to do this. We're going to full screen its ass. And we're just going to screenshot the full screen. Boom. Okay. Where's Adobe? Is it started up yet? All right, cool. What happened to clipboard? What happened to clipboard? Now it's there. Why wasn't it there? Guys, am I hallucinating? Or anti-hallucinating? What's going on? It never sees the clipboard on the first time startup. That's great. Yeah, small indie company, Adobe. All right, so we're now going to comment this out. And we're going to see what we like better. All right. Okay. So I mean, I'm not sure how much to zoom in to judge this, but here's the THICC constant size lines. They do look a little uggo up here, if I'm being honest. Oh, that's better. That's better, right? Right? Look at that. Look at that. That's pro right there. That is pro. Okay. We'll take the W. Now there is always a question. If you found this to be too slow to do, you would either figure out a way to do it faster, which certainly exists, or because the problem with this is it's not really a predictable branch, because you have to iterate. Actually, it's going to be predicted as false almost always because we almost never do it, but then we're going to do it and then we're going to not do it. And so, yeah, I don't know. I didn't check in the iterative, right? Make tree map generation iterative instead of recursive. And oh, you know what? I was dumb. Guys, I was dumb. I swear to you I was. In the following way. We're about to improve things again. Thin out the module border when we get near into smaller modules. Okay, guys, I was all proud of our iterative thing, and then I was typing, and I was like, what did I do? Okay, remember this size children that we literally just did? All we do here is add root.children down here. Root.children is not modified by any of this code. So we don't need to pass the stack. That's the stack jack. We don't need this to be here. We literally just do this. We could put an if statement around this just because there's a lot of leaf nodes. I don't know. But we could early out like up here somewhere. I don't know. Anyway, that's better. Well, it's not better because it doesn't compile. Oh, we gotta pointerize that. Ta-da! Like, come on, man. Well, how do we feel? I mean, I'm pretty good with this. Like, more of what I would want to do in the future is just using this to inspect the program, maybe adding more metrics or different metrics or something. Could you scale the border with the ratio of the area to the full area? Well, what I was saying was the very first border thing that we tried was scaling the border in both directions. And that I didn't like that because that made ugly things. And what you're scaling with area, the thing that does is, again, it mixes the two dimensions, right? So you can't differentiate between them. And so that would be kind of equivalent in some way to what we were doing initially in terms of how it looked, which I didn't like. Log transforming sizes probably wouldn't work due to a weird interpolation between function size and function count. Under log transform, a size 256 module with a single file has area 8, and a size 256 module with two size 128 files has area 14. Oh, yeah, I mean, that is an issue, right? It's like, at that point, like, size is not really representing something real, right? If you split something into two and it gets bigger, it's like, well, that's not great. Yeah. Anyway, I'm kind of tired now. Like, I was working real good this weekend. I did also go out and do fun things in between all the working, but we got it done. Thanks for hanging out with me while we did this. If you missed any episodes in this series, they will all be on YouTube soon, especially if you're watching this on YouTube now. Thanks a lot, and I'll probably take a break of a couple days before we stream some more, but you never know. Might do it right away. Thank you, everybody. Thanks for coming by. Good luck with your own projects. I hope they go well. Have a good evening or whatever time it is where you are.